We got a lot to do today. So best thing is to get started. One of the things I want to do today is I want to go over the homework. So anybody who has not submitted the homework, I won't be accepting homeworks after today because I'm going over it today. So that's number one. So we'll go over that homework we had to build the census database. And I'll walk you through those queries. And we'll do that in our SQL Server. Let me get rid of these tables here. Okay, and the other thing we're going to do today is I'm going to tell you about the group project, final project that we have in this class that you guys are going to do in a group. And what I did is I've assigned you all to groups. So let me show you those groups here. So group one is going to be Andrew, Alec, Nicholas, and Ruth. That's group one. Make note of your group number. Group two is Rhiannon, Keith, Zachary, and Peter. Group three is Joseph, Hannah, Brian, and Jonathan. Group four and group five each have an extra person. That's David, Rebecca, John, Edwin, and Nicole is group four. And group five is Michael, Brandon, Nina, and Zachary. Okay, so those are going to be your groups for the group project. And the group project, what I do there is, I base it on the output of the group, but each member of the group should have a responsibility for one of the deliverables that's part of the project. And we have essentially five, well, let me put it this way. Each group member should have responsibility for one or more of the deliverables that are part of the project, because some of you have groups of four, so somebody might have to do double duty. But the five things that you need to deliver is number one, an entity relationship diagram. Number two, a logical schema. Number three, the relational algebra expressions for 20 to 30 meaningful queries. Number four, data definition language to create the tables in the database. And number five, the 20 to 30 queries implemented in SQL, with 5 of them implemented via JDBC and Java, which we're going to learn later in the semester. So this is what you're going to produce. And the data that you're going to use to produce this, you're going to look at this, this set of free data that's at this link right here. So we can open that link. And you'll see there's all kinds of interesting data here. Bureau of Labor Statistics, Bureau of Economic Analysis, IMF economic data, Dow Jones Weekly, all this good stuff here. And to put together 5 entities, you may have to combine multiple data sources. So you might have to combine some of this with the census data or whatever. But these are the data sources that you're going to use for your assignment. And hopefully you're going to mine this data in some kind of interesting ways as part of your group assignment. So, I wanted to introduce that to you. Obviously we've learned some of these things. We haven't learned other things. We're going to learn about entity relationship diagrams after intermediate SQL in our next section. We're going to learn some more about queries in this coming section. So, you're going to learn more of this stuff. But I did want to get you thinking about these assignments or this assignment and start to talk about it with your group as to who's going to own what. Because some people are better at the logical type of design. Some people are better at the programming piece. So you guys can decide how you best want to organize to do this. And the first milestone that you're going to have for this project, if you go down to that exams and projects section, is on November 9th, I'm going to ask you to select your data set and define your roles across those different elements of the project within your group. Okay, so that's going to be due on November 9th. So I wanted to give you a heads up on that so that you can get started working with your group and talking with your group on how you're going to manage this group project. Does anybody have any questions on that or any comments on that? All right. So, there are essentially three deliverables over the course of the semester for this. One is the roles and responsibilities and the data set. That's the first one. The next thing is you're going to define what the five or more key entities are in your data model. And then the last one is you're going to deliver the project at the end of the semester around December 13th. Okay, so you'll see each of those under exams and projects here. You'll see each of those milestones for this project. The other thing you'll see here is we've got our second exam coming November 11th. So you'll see that here also. You won't be able to see the exam because it isn't available until November 11th, but we're going to have that second exam November 11th. Okay, so that's our schedule. As for today, we're going to be covering intermediate SQL. We're going to continue to cover intermediate SQL. The next thing after that is going to be the ER modeling, how to draw the diagrams, and then we're going to do the JDBC stuff. So, you'll have everything that you need to do this project by the end of November. Okay. Any questions on that? Any comments? Okay, so once again, the groups. Group 1, Andrew, Alec, Nicholas, and Ruth. Group 2, Rhiannon, Keith, Zachary, and Peter. Group 3, Joseph, Hannah, Brian, and Jonathan. Group 4, David, Rebecca, John, Edwin, and Nicole. And Group 5, Michael, Brandon, Nina, and Zachary. If there are any scheduling reasons why you may want to switch groups, you just have to arrange it with the other group accordingly. If you can arrange a swap and just let me know about that swap and I will make the changes accordingly, but both groups have to agree to it. Okay. All right. So that's the first order of business. Second order of business, let's go over the homework. So in the homework, we were going to build the census database. So I'm going to go through that process right here. Get rid of all this stuff here. And we will start from scratch. I don't know why my database is so slow today. Go. 2, 3, and 4. All right, so what I did was I created a new data. Let me get rid of that too, so we can start from the beginning. Delete that database. Okay, I didn't ask you to do this with a query, but all I did was I created a new database. I can right-click on database and hit new database, and it'll create a new database that way. Some of you actually wrote the query to do this. You wrote create database, and I'm going to call it census database 2. I already have my census database here. I don't want to overwrite that. Okay, so you can certainly create the database that way. And when you refresh your list of databases here, you'll see that I now have a census database 2 here. And per the assignment, you right click on that and you hit tasks and you hit import data. And you're importing from an Excel file, and you find the Excel file, which you probably have downloaded. You've downloaded from the assignment. I'm going to find it in my directory where I've kept it. There it is. And you open that data file. Mine is on the network, so it takes a minute to download. And you hit next. Oh. That's weird. I've done this before, so I know it can be done. Bear with me a second. Microsoft Excel. There we go. Browse. Oh, that's very odd. All right. But he's changed the configuration of my machine. Oops. All right, we're going to have to do this a different day because something happened to my machine configuration here. Let me exit this and see if I can go back in. Maybe I need to reboot. Yeah. Well, I'm not going to reboot. It's very strange. All right. We might have to go over this homework a different day. So I don't know why it's not working here. It shouldn't matter. Okay, let me add it locally. You're right. Let's try it. Let's see if that works. If that doesn't work, we might have to do this later on. Oop, not shortcut. Let's try that one more time. And if we can't do it, we'll do it later on. Let's change the permissions or the installation on my system here. Nope. All right. We will go over this homework in our next class. Let's go on with intermediate SQL. I'm not going to, oh, what's that? Might have had two windows open. Let's try one more time. If not, we'll just go on with intermediate SQL. Nope. All right. So let's continue with intermediate SQL. We'll come back to that. All right. Here we go. When we left off last time, we were talking about the new syntax that we were going to use for joins. And I just started talking about the different kinds of joins. And in your materials here, they teach about a natural join. And a natural join is when you join two tables on the fields that have the same name. So, you know, if you have an ID field in one table and an ID field in another table, you know, and you do a natural join on those tables, any fields that have the same names will be used as the predicate for that join. And editorial opinion from Professor Weiss, is it's stupid and dangerous to do a natural join, so don't do it. You know, I do have to teach it because it's in the book so that you guys know what a natural join is. But, you know, I think my view is it's better to be explicit about what you're joining the two tables on rather than using the default, you know, things that have the same name. So my suggestion to you is, you know, read about natural joins and know what a natural join is, but don't ever use it, okay? So that's piece of advice number one. So we're going to skip over natural joins. You know, as you can see, I hit a lot of the data here, but we're going to move on to outer joins. So let's do a join here. Let's start with doing a simple join here. So I'm going to bring up my SQL Server Management Studio. At least this I can do. And we're going to be operating on the census database. So here is the census database. We're going to go into that. And we're going to write a query. We're going to select from geographic area. And we're going to use this new syntax for the join, which is join. We're going to join that with our population metrics on geographic area dot FIPSNUM equals population metrics dot FIPSNUM. Okay, so that is our syntax for this join. And when we run this simple query, oh, I forgot to put the fields, star, sorry, there we go. Select star from geographic area, join population metrics. There we go. And when we run this query, we get a bunch of things. You know, we get all of the metrics and metric names and metric values, where the FIPSNUM and where the FIPSNUM is equal in the geographic area table to the population metrics table. So you will see all of that information. And if we look at the number of fields that we wind up with 327,300 rows, you know, which is the number of, essentially the number of equivalent rows across these two tables. All right, but I wanted to show you that join. You know, and I think we discussed this last time, that this query is essentially the same as the query that we learned earlier, which looked like, I'm going to make a copy of this. Which looked like this. And if we run the same query, we get the same results, you know, the 327,300 rows. So these two queries here are equivalent. Okay. So why do we have this second syntax? Well, the reason we have the second syntax for these things is that we have different joins that we can do. As I mentioned last class, if we do a left join returns all of the values of all of the records of population metrics whether they have a matching record or not. And if they don't have a matching record, it will return null for the corresponding values of population population metrics. If geographic area, so let's show that. So what I'm going to do is I'm going to insert a new record into geographic area. So let's do that. We're going to make a new query. We're going to insert into geographic area. So the fields of geographic area are, or the columns of geographic area are FIPSNUM. Values. Okay, so we need to insert a FIPSNUM. I'm going to make up a new FIPSNUM. It's going to be 99999. Okay, the state is going to be U.S. Virgin Islands, or Virgin Islands, because it has to be 2 characters. Okay, the area is going to be St. Thomas. And I'll make up a rural urban continuum code. I'll make up an urban influence code. And I'm going to make up an economic topology. Okay, and I'm going to run this query. And it will insert St. Thomas into my geographic area table. Now, the reason I do this is we don't have any census data for St. Thomas. So there are no corresponding records in population metrics for St. Thomas. So if I do a join, save this, call it, save this out. Census database. Add St. Thomas. Okay. So if I do a join now, well, first we'll do a select from geographic area. Just to show that St. Thomas is there. And if we look down the line, we see at the very bottom, we have a new entry, St. Thomas, Virgin Islands, that we just added here. You'll see that that's there. Let me make sure I didn't reuse a FIPS number here. Okay. Good, I didn't reuse it. All right, so you'll see St. Thomas has been added there. And now if we do a join of this, join population metrics, on geographic area dot FIPSNUM equals population metrics dot FIPSNUM. There we go. Even though I added St. Thomas now, you'll see that we're still getting those same number of records, the 327,300 records, because it didn't find a match for St. Thomas. We can scroll to the bottom and we see St. Thomas isn't there. It didn't find any match for St. Thomas in population metrics. So since there were no matching records between those 2 tables, the St. Thomas entry doesn't appear in this join statement. So that's a regular join. and we can validate that, we can say where area equals St. Thomas, and we'll see that there's no record return there because it didn't find the match in population metric. Does everybody understand that? Does everybody understand why St. Thomas doesn't appear there? All right, but we're going to change this slightly. Now we're going to do a left join here. And what the left join says is, even if there's a record in geographic area, the left table in this join, that doesn't match population metrics, I want to include it in the output, and I'll just leave no values for the values that would have come out of population metrics. Okay, so let's see what that looks like. So when we run this query this time, we do get a record for St. Thomas. And you'll notice that all of the fields from population metrics are null. Okay? So that's a left join. What it does is it takes all of the records in geographic area, and for the ones where it has a match, it will fill in the proper values from population metrics. But from the ones where it doesn't have a match, it will still include them, include null values. Okay, so if we saved out this, we could say where population metrics dot, pick any field, we'll do ID, is null. This will tell us every area that we have in geographic area that doesn't have any population. Okay. So that's a left join. Now what I'm going to do I'll save that also. And I'll call it geographic areas with no population metrics. And now what I'm going to do is I'm going to write a query, delete from geographic area where area equals United States, single quotes. So I'm going to delete the record that corresponds to the United States from geographic area. It deletes that one row. I'll save this as delete United States. Delete United States from geographic area. And I'll reopen this, or I'll do a new query here. I'll do select star from, geographic area. Join population metrics on geographic area dot FIPSNUM equals population metrics dot FIPSNUM. And I want to find all the places where geographic area.id is null. Okay, because this time, instead of doing a regular join, I'm going to do a right join. So this will include all records from population metrics, whether they have a match in geographic area or not. And when we run this one, we'll see for FIPS number 0, which is the United States, where we no longer have an entry in geographic area, we get all null values in geographic area, and we get the United States population metrics. So that's a right join, and right join includes all the records from the right table that have no match in the left table, whether they have a match in the left table or not. Okay, does that make sense? Any questions on that? Okay. So now what we're going to do is we're going to do an outer join. That includes all records from both tables, whether they have a match or not. And here we're going to do it for those things in geographic area that don't have a match in population metrics, and those things in population metrics that don't have a match in geographic area. A full outer join, sorry, full outer join. There we go. So we get all those records that have null values for geographic area, and the one record that has the null value that's in geographic area that has null values in population, or doesn't have an entry in population metrics. Okay. So you have a left join that will give you all the records in the left table, whether they have a match or not in the right table, and fill in null values for those that don't have matches. You have a right join, which will give you all of the values in the right table, fill in nulls for the ones that don't have matches in the left table. And then you have a full outer join, which will give you all values in both tables, with nulls in the fields for the other table if they don't have a match in the other table. Yeah, Nina. The left join will have all the records in the first table, whether or not they have records in the second table. The right join gives you all the records in the second table, whether or not they have records in the first table. And the full outer join gives you all the records in both tables, whether or not there's a match in the opposite table. Did I explain that okay? Any questions on those? Do you understand the difference between those? And this gives a good way for how it's used. We use this part to find any geographic area that didn't have any population, any census data associated with it. And it also helped us find any census data that didn't have a geographic area identified for it. Okay, so that's how we use these outer joins. And as I said, we have the three varieties. We have left outer join, right outer join, and full outer join. Okay? So here is the definition. It's an operation that avoids loss of information. It computes the join, the ones that are matching, and then adds the tuples from any relation that doesn't match tuples in the other relation. Okay, so that's an outer join. Okay, I'm not going to, once again, the natural join, I'm going to ask you to just read up on and then forget about it promptly. I never want you to use it in this class. Okay, any questions on the different varieties of join? So if we don't have a keyword on the join, if we don't say it's an outer join or a left join or a right join, it is what we call an inner join. That means it will only return those records that match across the two. If it doesn't have a keyword, it's an inner join, which means it will only return the records that match across the two tables. So, let's look at the effects of this. An inner join, if we do an inner join of these two tables, we have 327,200 records. If we do a left join across these two tables, we'll get the one additional record for the Virgin Islands that doesn't exist in the population metrics. So we're going to get 327,201 records, will be my guess here. And sure enough, we got 3,207 or 327,201 records. If we do a right join, we'll get any population metrics for the United States that don't appear in the other table. And that'll be the number of years, which is like 10 years worth times about 7 metrics. So 327,200, roughly 70, I'd say. Oh no, more than that, 300. Okay, 327,300. And if we do a full outer join, we'll get 327,301 because we'll have that additional record. Okay, and sure enough, there we have 327,000. Right? So a full outer join returns the most records, obviously, because it's giving everything that's in either table, whether it has a match in the corresponding table or not. And the other ones give slightly more than that, with the inner join giving the least because it leaves out the records that don't match. Yeah. Yeah, so the way to find the records that don't have matches is the way that I did earlier. You have to add a where clause that tests for a null value in the opposite table. Okay, so if I want to find the records that don't have values in the opposite table, if I want to find the records, hang on, Michael, I'll get to your question in a second. Okay, if I want to find the records, I'll get to your question in 1 second. If I want to find the records in geographic area that don't have a match in population metrics, I would check that the population metric, one of the population metrics fields, in this case ID, is null. Okay. So this shows me all of the records in geographic area that don't have a match in population metrics. And likewise, if I want to find the records in population metrics that don't have a match in geographic area, then I could check as to whether a geographic area field is null, in this case, the ID. Okay, so let's run that. And there were actually, I think, 100 of those records, which surprised me, but there are. You can see United States has births, deaths, all these different metrics for years 2010 through 2019. So there were 10 different metrics, 100 or 10 years. So 100 different metrics that didn't have a match in geographic area table. Okay. Okay, and Michael's question, can you use this instead of an and? It depends on what you're going to query, but no, I mean, generally you can't use it instead of an and because an and is the intersection of things, and this is more a superset of things. So generally, no, I mean, this isn't equivalent to doing an and. Okay. All right, so that's, you're welcome. Oh, you can use, I understand your question now. If you're asking, can you use join on instead of anding the join predicate with the select predicate? Yes. The answer to that is yes. So I misunderstood your question. All right. Any questions on these different varieties of joins before we move on to the next important construct? Okay, the next thing that we're going to talk about is views. We talked a little bit about views early on when we were talking about relational concepts. You know, if we look at Canvas, for example, you know, when I look at Canvas, when I look at our modules page, I see all the modules, whether they're published or not. This is my view of the data that's in Canvas. You know, this is the professor view or instructor view of the data in Canvas. But you'll notice I have this thing called student view. This is something that lets me know exactly what you guys see. Let's click on that. And you'll see that you have way fewer modules than I do. You know, you get a restricted view of the data that's in Canvas, right? So there are two different views. It's the same database. You know, this has the same assignments, same grades. Everything is the same in this database. But what it's doing is it's presenting a different view to me than it is of that data than it is presenting to you. So what databases allow you to do, and I can leave student view and go back to my instructor view. So what databases allow you to do is they allow you to provide views of the same data. So what we're going to do is we're going to create a view of these population metrics. And the view that we're going to create, let me get to it. There we go. That's the intro to SQL. Hang on. Intermediate SQL queries. There we go. The view that we're going to create is, I want to create a view for the maternity ward of a hospital. I want them to be able to update the births in this database, but I don't want them to be able to update the deaths or the total population or anything like that. So what I'm going to do is I'm going to create a view. And that view is going to be the only thing that a maternity ward can edit. And the way I'm going to create that view is I'm going to use a view statement. And the view is going to be defined by a select statement. And the select statement is going to select the fields that I want to allow them to edit or to look at or change or whatever, you know, it'll define the fields that are part of their view by joining geographic area. Oops. Replace some of these things with brackets. Believe it or not, we were going to use a different database system at one point, so that happened to use single quotes instead of brackets. So I've got a join statement that's going to join geographic area and FIPSNum, and population metric on FIPSNum. But it's only going to show in the view the things that are related to birth metrics. So the metric name here, you know what, I'm just going to replace all the single quotes. Hang on. Oh, that's not going to work. All right, so we'll change all these to brackets. Will be brackets. There we go. All right, yeah, and the only thing that should be in quote is births. There we go. So we're creating this birth view by joining the two tables together. selecting the fields that we want from those two tables, joining the two tables together, and we're only selecting those records that correspond to births. So when we run this query, oh, I missed one. Oh, there it is. Save this. When we run this query, I had a births view in here already. Let's get rid of births view. One more time. When we run this query, it will create a new view in our database. And that view is births view. Okay. And if we look at births view, create a new query to look at births view, you know, we can look at this exactly the way we do a table. We'll see that births view contains only those records that correspond to the metric name births. So if we scroll all the way down here, all we see here are births. We don't see anything else but births. And we see the metric values for all of those things that have to do with births. Okay. So we've defined a view. Now, what's the difference between a view, let's say, and just the output of the select statement? Does anybody have any ideas on what the difference might be between this view of the data, just the select statement or join statement? Okay, well, the difference is if we update something in this view, we're not just updating it in the view, we're updating it in the table that it came from. Okay, so any changes we make in this view, to any fields in this view, get put back in the original table. Okay, so what I'm creating is I'm creating essentially pointers back to the original table. This is not new data. So anything that I do to this data gets changed in the original tables. Okay, so let's see what that looks like. Okay, I'll do one more view. I'm just going to do Alabama births this time. You know, let me create a new view. I'm going to create a view from births view. I'm going to create a new view called Alabama births. And in this case, the state is equal to Alabama. So, you know, you can create a view from a view. And when we open the views, we'll see we've got an Alabama births view, and we can select star from Alabama births view. And we'll see that that contains just the births in Alabama, you know, in the various counties in Alabama. So that's yet another view that we can create. So you can create views from views. Okay. And what I'm going to do is I'm going to update that Alabama births view, and I'm going to set the metric value number 1001, year 2016 to 600. So before we do that, let's see what that value is now. Select star from Alabama births, or yeah, from Alabama births. Where? Just copy and paste that where clause.
there's those stupid single quotes again. There we go. So we see that value is 666 right now. And what I'm going to do is I am going to change it to 600 instead of 666. So let's run that query to change it in Alabama births. Okay, so we've changed it in Alabama births. Let's run that query that we just ran to make sure that it's changed in Alabama births. So it just got changed to 600 by that update command. Everybody see that? And now what we want to do is we want to see if it also got changed back in population metrics. So we'll go back to the original table where that metric came from. And we run it and we see that it also got changed. You know, that's the births metric. It also got changed in population metrics. Does everybody see that? Okay, does everybody understand what a view is? So a view is a restricted portion of the data you're making available, and you can grant access to views to different users of the database separately, so that all they can do are operations on that view. And that's how you restrict the database to different user types and different roles in the database. So, you know, if I were doing this for Canvas, for example, I would have my database of all my assignments and all my grades and everything, and I would create a view for the instructor, and I would grant certain rights to those instructors to do different things on that view. And I'd create a separate view for students. And the students would have only the right, for example, to select things where the ID card is on. Okay. So that's views. Does anybody have any questions or comments on views before we go on? Okay, so we went through view definition. You know, we do the create view, and we can use a query expression to specify what that view contains. We did a view using another. We defined the view using another view. We created Alabama births from births. Okay, view expansion. So what you can do, what I can do now, is I can take Alabama births let me exit out of these. Save this. Save this. Oh yeah, let me change the value back. No, I don't want to do transactions yet. Bear with me a second. Okay, what I can do is I can define yet another view. And here I'm going to create view Alabama all. And what I'm going to do is I'm going to select distinct FIPS-num from Alabama view. And I'm going to join that with population metrics. FIPSNUM. So I'm going to select those things that are distinct from Alabama View Joint Population Metrics on Alabama View dot FIPSNUM equals population metrics dot FIPSNUM. And what this is going to do is this is going to get all of the population metrics corresponding to the Alabama areas, not just births, but deaths and everything else. Okay, so let's do that. And that will create a view that has all of the, oh, I forgot as. Okay. Oh, Alabama births, gosh. I am losing it. There we go. There we go. Hang on a second. Oh. Bam. Oh, yeah, okay. Yeah, these fields are in both tables, so we got to specify. All of these are non-unique names. Population metrics FIPSNUM could not be found.
Professor?
Oh, yeah. Thank you. There we go. All right, so we created it. Thank you. We created a new view here, so we can look at that view now. And what we did was we expanded the Alabama births view. You know, we started with the Alabama births view, and we expanded it to include new fields, or not new fields, but new elements from population metrics. So we can look at that view now. There we go. So we'll do a select star from Alabama all. Make sure I got the right underscores here. And we'll see we now have, you know, the population metrics for all of the Alabama. We have all of the population metrics from all of the Alabama counties. And we've created a new view based on that. So, you know, you can use views as a starting point and create from those views with the original, you know, using the original tables, for example. And that's called view expansion. Okay. All right, so that's view expansion. Yeah, some databases allow you to create what's called materialized views, which are essentially not just pointers back to the physical table, but essentially just it will actually store those views physically rather than just point back to the table. And in those cases, for those systems, you need to maintain the view separate from the source data. So, that's not the case here in what we're doing, but you should be aware of that, so that that may need to be done for some views. Okay. All right, so any question on views? All right, the next thing we're going to talk about is transactions. So let me show you what a transaction looks like, and let me tell you what a transaction is. So before we do that, okay, here's a transaction. What a transaction is in SQL is it's a set of related statements. And what you want to do, you want to build transactions so that if one of those things fails, for whatever reason, both of those things, neither one of those things will be executed. So for anything within the transaction, if any one of these things fails, the whole transaction will fail. Okay, and we talked a little bit about transactions early on. One example that we used is if you're doing a funds transfer, you're transferring money from one account to another account. You don't want to delete the money from the one account until it appears in the second account. Right? Likewise, you don't want to add the money to the second account until it's subtracted from the first account, because if there's a failure anywhere in the middle there, you'll either have double the money or you may lose the money, right? So the purpose of a transaction is to make sure that anything that's within that transaction either totally succeeds or totally fails. And the syntax for a transaction in SQL is you have begin transaction, then you have the statements, and then you have the commit transaction. Okay, so in this particular case, what this transaction is going to do is it's going to update both 2016 and 2017 current metric for PIPS number 1001. Okay, so we run that transaction, and that transaction only affected one row. I'm surprised by that. So let's look at that. I'm going to create a new query. Select star from Alabama births where PIPS num equals 101. I got the right PIPS num there. Yep. So let's see what those records look like. Okay, so we've got 666 and 676 for 2016 and 2017. Let's change them to 600 and 700. And we'll run this transaction. And then we run this again, and we see that those get changed to 600 and 700. Okay, so both of those statements got executed. There's no surprise there. So now what we're going to do is we're going to, bear with me a second. find a good transaction here. I've got so many examples. I should have numbered them to keep them straight. Okay. The other thing that we can do in a transaction is we can roll that transaction back. So let me hang on a second. This is not a good example. Do this back to 666. Oh, sorry. I'm going to find a better transaction for. Okay. So here's what we're going to do. Hang on a second. Okay, so what causes a statement to fail in a, if I try to do an update, what will cause that update to fail? Well, if you remember, we defined foreign keys between geographic area and population metric. We have population metric has a foreign key of, hang on a second, let me double check the foreign keys here. Here we go, constraints. Yeah, so what I did was I set up population metric so that it refers to the foreign key FIPSNUM. No, I haven't done that yet. All right, let's do that now. All right, so what I'm going to do is I'm going to make FIPSNUM the foreign key in population metrics referencing geographic area. So let's do that now. We're going to make population, we're going to make FIPSNUM the foreign key in population metrics referencing geographic area. Okay, first we have to make FIPSNUM the primary key in geographic area. So let's do that. You know what? I'm going to save this for the next class. We're at 12:08. I'm going to save this for the next class. I want to make sure that I've got this running more smoothly before we do this. So I'm going to save the transactions for the next class. We're going to end here for today. You know, we're going to end on views for today. And we will do transactions in the next, integrity constraints and transactions in the next class. So let me end it there. One thing I do want to point out to you or remind you of before you do leave today is I'm going to remind you have this additional assignment to do your simple SQL queries. So you'll see query census database. You've got about 7 multi-part queries to do here, or 7 different areas of queries to do here. So that is due Thursday. So don't forget that. It downloads fine. You mean when you try to open it? You shouldn't be opening it. You should be putting it into the backup directory. So the instruction, yeah, let me go through how to do that with you guys in the few minutes we have left. In fact, I should do this because I've been messing with my this database. So what I do is I take that file, I downloaded that backup file. Here it is, census.back. And I can cut it. I'll do a Control X to cut it, or I can do a right click and cut it. And I go to my program files directory. I've installed Microsoft SQL Server. And I go to the SQL Server directory, which is here. And I go to my version of Microsoft SQL Server. And I go to the backup directory. And I paste it into that backup directory. Okay, I'll replace the file in the directory. And then what I do is I go into my SQL Server. And I can right click on the database. And I'll say restore database. And the database in this case would be the census database. And I would select that file by hitting add. And then I hit all the OKs. And it will restore that census database. It'll put all those tables and things in the database. And if you have any questions on how to do that, I did include a very nice video for that. Oops, let me share that. Which is right over here. Okay, so this does it for VMware. You can skip the VMware piece if you don't have VMware. This tells you how to log on to VMware and do all that stuff. So, this will tell you how to, it shows me copying and pasting that file into the Microsoft SQL backup, SQL Server backup directory. Okay, so you just need to follow this video and you'll be able to do that as well. Okay. Hannah had a question. Yeah, I will be uploading the queries we did in class. That probably won't happen until tomorrow though, Hannah. Okay. All right, so I'll end it there. And we will pick up next class with transactions.